Hope you're ready for your second video in algebra. As you looked this weekend and tonight, we're going to be talking about sections 1, 3, 1, 4, and 1, 5. Now, a lot of times they've grouped these sections together. There's a lot of vocabulary you're going to see again. As you're looking at this, one of the things we are looking at is that when we talk about square roots of a number, if b to the second power equals a, then b is called the square root of a. So when we say 3 squared equals 9, 3 is a positive square root of 9. But another thing to keep in mind is that negative 3 squared is also a square root of 9. If you look at your vocabulary notes that you have for chapter 1, we're going to have you continue to fill them in. A lot of the vocab you're going to see today, square roots, radicals, all the way through inverse property of addition and the subtraction of real numbers. So I'm going to have all of these filled in for you. You can use your textbooks, you can go online, you can use other sources to find these. As we talk about square roots, all positive real numbers will always have 2 square roots. So a positive square root and the negative square root. The symbol that's used is called the radical symbol. This is a square root symbol often referred to. So when someone talks about being radical, they're not talking about being out there, but it's used to write our square roots. The number expression under the radical symbol is called the radicand, and you can see that looking here. No, the radical symbol indicates the principal square root. It's non-negative. So if we think about the square root of 49, the square root of 49 is 7. What about the square root of 0? The square root of 0 is 0. Sometimes you're going to see the positive square roots looking. Square root of 16 is 4. The negative or opposite square root of 16 is negative 4. And if you ever see this plus minus symbol, it's just telling you of an option of 2 answers. The first one is positive 4, the second is negative 4. So this answer could also be written as 4, comma, negative 4. Here's the list of the perfect squares. Again, as you're watching a video, you need to pause it to get these down. You really should have memorized the first 12 perfect squares. So what are the perfect squares? That's this second column here. The 1, 4, 9, 16, 25, all the way to 100. And again, these ones aren't too hard to remember if you know your multiplication facts, but really up through 12. Other ones that are important that you'll see a lot, 15 squared comes up quite a bit, 20 squared, and if you think about 30 squared, what would 30 squared be? Well, 30 squared would be 3 squared, which is 9, so you're going to have 900. So you can think of some of those other numbers that you can probably look at. As you look at this, the perfect square, so if we look at a number, the number squared is called its perfect square. So 3 squared should be 9. 4 squared, 16. Now from the last table, you could fill these in, and so we are looking at our first 12 perfect squares. If we're simplifying square roots, and you're looking at the square root of 64, what is the square root of 64? The square root of 64 is, if we think about what number times itself gives us 64. So 8 times 8 is 64. The square root of 64 is 8. Again, looking at your 20 perfect squares, going from 1 to 20. 4, the square root of 4 is 2. So if we're looking at this, these are our perfect squares, going from 1, and in this case this should have been 100 down here, not 10. The square root of 10 is not 10. The square root of 100 is 10. So if you look at this list, that was a typo on my part there. Now the other thing you're going to be asked to do in your homework is to estimate. When we estimate, there's 2 ways of doing that. You could use your calculator and use the square root symbol. The other thing is you can think about the square root of 12 is somewhere between 9 and 16. 9 and 16 are our perfect squares. And if we're thinking about what is it closer to, 9, 10, 11, 12, 12 to 16, we're going to be talking about 4 units there. And we're talking about here the 3 units. So which is it closer to? It's a little closer to 9. So if we think about the square root of 12, it's probably closer to the square root of 9, which is 3, the square root of 16, which is 4. So the square root of 12 is going to be somewhere between 3 and 4. So if we're looking at that, we might put the square root of 12 somewhere along here. Where's the square root of 87? Again, think your perfect squares. It's between 81. Square root of 81 is 9. And it would be between 81 and 100. And the square root of 100 is 10. So the square root of 87 is going to be somewhere between 9 and 10. And you can do that for each of these. The square root of 5 is between 4, our perfect square, and our perfect square of 9, which is quite a bit closer to the 4. So we are going to place square root of 5 closer to 2 if we are looking at that than 3. Square root of 49, and I love that one. It's one of our perfect squares. Square root of 49, it is 7. The square root of 34, well, it's between 36. And if you look at your list of perfect squares, 36, the one below that is 25. So it's going to be in between those two squares. If we're estimating the square root of 34, they kind of take you through a process here, thinking about where's 34 on the number line. And so 34, if we are looking at that in comparison to our other numbers, the key thing I want you to think is 34, is it closer to which two perfect squares? Well, it is closer to 36 than to 25. So if we're going to place square root of 34, it should be closer to 6 than it should be to 5. And if we're going to estimate it, what integer is it closest to? It is actually closest to 6. Sometimes we'll use calculators. One of the other things you're going to be looking at is all the sets of numbers. Now I know you've seen some of these before. Real numbers is every number on your number line. So as you fill in your notes and you're looking at these, different ways of thinking about it. Numbers that exist in the real world. It can be fractions, decimals. It can be irrational or rational numbers. So you see this irrational over here and rational. This is the big letter R that is often referred to that. So we talked about our other number sets. Inside, we have what's called our irrational numbers. Well, if we break this down, we're going to look at the real number system. We're first going to look on this side of rational. Rational is a number that ends, or it might have a repeating pattern. A lot of times we're going to say for rational, it's a number that can be written as a fraction, A over B, that has a ratio. So it can always be written as a fraction, A over B, as long as B is not 0. So that's a key thing to keep in mind with rational. Our integers are part of the rationals. Integers are positive, negative numbers, and 0. Notice you have no fractions or decimals here. So it's your positive, negative, whole numbers. Well, what are the whole numbers? So that's our next set that we're looking at. Whole numbers are going to be all of our whole numbers are non-negative integers. So if you think of that, we are talking about 0, 1, 2, 3. Continue up as high as you can count. The natural numbers do not have a 0 in it. They start with 1. So natural numbers plus 0 gives us our whole numbers. The whole numbers plus their opposite gives us the integers. The rational is all of these sets plus fractions and decimals. When we talk about irrational numbers, those are numbers that do not repeat and do not end. So what you're going to look at here is I want you to think, if you had to put these numbers in the correct section, where would they be? I'm going to have you pause the video and kind of think about this, and we're going to kind of talk it through in just a minute. So if you need to pause it, pause the video. If we're talking about the number 0, 0 is a whole number. Negative 5/7, well, it's a fraction. Negative 5/7 is going to be rational. Negative 16 over 4, well, what does that really equal? It equals negative 4. Well, negative 4 is an integer, so we put negative 16 over 4 as our integer. If we are looking at 4/3, 4/3 is a rational number. It's going to end up being repeating. Pi. Never repeats, never end. Very irrational. Square root of 81, it's a perfect square. 9. 9 is a natural number. It's a whole number. It's an integer. It's a rational. The most specific one we would put square root of 81 is a natural. 10 divided by 5 is equal to 2. That's also a natural number. So 10 divided by 5. 2 is a rational. It's whole. It's an integer. And so it fits into all 4 of these sets. Square root of 2. irrational. -6. -6 is an integer. 0.3. 0.3 is going to be an ending decimal, rational. You could also place these other numbers. If you would look at placing those on your chart, you could also. So one of the things that they're going to talk about in classifying is that we can use a set notation. That's these brackets, squiggly line brackets. A set is a well-defined collection of objects as you're filling in your notes. Each object is called an element of the set. A subset of the set consists of elements of the given set. We usually list our sets in these brackets. So what are the natural? 1, 2, 3, ... Whole numbers, 0, 1, 2, 3. Integers. These dots tell us it goes on forever. Then we have -1, 0, 1, 2. So if we're going to be classifying in your homework tonight numbers as either rational or irrational, remember, rational ends or repeats, irrational does not. So if you're going to cross these out, we'll look at those tomorrow in class. Irrational number cannot be represented as a quotient of two integers. In decimal form, irrationals do not terminate, never ending, never repeating. So pi and square root 2. I'm also going to have you look at this chart, and we're going to talk about this a little more tomorrow in our notes. It's getting close to the end of this lesson, so what I need you to do is, again, you're going to see this. If we were going to place those numbers, where would they be? We will be using our calculators tomorrow in class, so make sure you have your calculator with. We want to make sure you know how to put in the square root of 129. And how do you get that rounded to the nearest hundredth so that we can approximate it? We will be using our calculator for that. And so that then we can actually compare, is it rational or irrational, and how we can compare our numbers. So we're going to work with both numeric and algebraic expressions. More notes for you. How are numbers related and our properties? You're going to see quite a few properties coming up. We're going to be talking about equivalent expressions, which have the same value for variables. Deductive reasoning is in your notes. We're not going to be using it a lot right now, but it's just a process of reasoning logically to make our conclusions. And then we'll talk about the statements, something being not true. If you can give an example that it's not true, that example that is false is called a counterexample. So a false example of something is called a counterexample. So this is more vocabulary, math vocabulary we will use throughout the year. Here are your basic properties we will be working with, and some of these you've probably already seen before. We start with commutative property of both multiplication and addition. We go with associative property of both of those. We talk about the distributive property, the additive identity, the multiplicative identity, the additive inverse, and the multiplication inverse property. So when you look at these properties, they're not really that hard. They're just the ways that we can relate to numbers. The zero property of equality is the last one. Sometimes I'll have students make up these kind of flippable notes. So if they want to understand the properties better, they put the vocabulary term on the outside, and the inside they write in a certain note. This is a note system that helps you. By all means, use it. You will need to know these properties. So what I'd have you do here is you're going to have statements A through H, and you're looking at here, if you want to think about this, commutative property of addition, A plus B, B plus A. So I'm kind of giving you an example of what those look like. What you're now going to do, again, is you're going to match these from column A to B. So when we come into class tomorrow, we're going to be looking at these properties, and we're going to try and make sure we can match them up and that they make sense to you. And we'll talk about them a little more in class. Be ready, have your notes with the properties. The other thing we'll talk about is the absolute value of x. How far it is from 0, that's what absolute value means. It does not mean in what direction, it just means how far. We're going to talk about the rules of addition. So if you look at these, if you need to pause the video, you could. And then we are going to fill in these notes. We'll kind of work on these together. This one note sheet, 1-1 to 1-5, I'd like you to do your best to fill this in when you come into class. We're going to answer questions and work on some homework tomorrow in class. And I hope this helped you out and you understand these a little more, but we will take more time tomorrow.